Okay, now before we go to our speaker, I do want to mention something about the careers. Since today is about how to become a data scientist, I did go to the link that is in the slide deck, pass.org careers, and then I got a 404 error. Okay, so, but I did click the link, and when I clicked the link, I did see many jobs on the PASS website. However, when I searched under job function data scientist, there were no currently available jobs in the area of data science. However, there's many other excellent opportunities out here, and I can see what some of them are. A lot of them are web application, database administrator. So if those are your topic areas, then you can talk about that. And I'm sure our speaker, Brad, will tell you where to find the data science jobs. Where are you going to find those jobs? We are going to have some polls, and I'm going to run one of them right now. So these are going to be polls, first of all, on describing your career today. So you should be able to see that poll now on your screen, and go ahead and fill that in. And right now, I can see that we'll run that for a little while, and we'll get some responses. Right now, we got a 20% response rate, 30%, 40% response rate, 50% response rate, 60. Show those results. So right now it shows that I am sharing the results from this poll. You should be able to see that there. Well, what I see here, the predominant attendee today here is working in databases, but want to transition to data science. And thank you also for attending today. If you're not in technology, certainly we feel that there are careers in data science, and Brad will be able to share that with you as he gets into his presentation. Now, let me go ahead and introduce our speaker today, and let me pull up his bio. Brad is Senior Data Science Consultant in Centelli Solutions, Charlotte, North Carolina. And I don't know if that's, I've seen two here, Valorum, so Brad, you're gonna have to clarify that for me, because I've seen two things on your bio. But he has a Master in Science in Statistics from the University of South Carolina, and also the MCSE, that's a Microsoft certification in data management and analytics, also MCSE certification in cloud platform and infrastructure. And so he's also on LinkedIn, Twitter, and also, by the way, I'm also on LinkedIn and Twitter, and we'll be sharing that information later as we have that those links put up.
Hello, everyone. My name is Brad Llewellyn, and I'm a senior data science consultant. And a lot of what I do revolves around helping organizations and individuals understand what data science is and how they can make it work for them. And one of my true passions is helping individuals advance their data careers and land that dream job that they really want. A lot of this presentation is based on a lot of the mistakes I've made throughout my career, hoping that you can all learn from me, and some mistakes I've seen other candidates make being on the other side of the table. We'll also talk about the 3 different types of data science roles that I've seen a lot of throughout the industry, and specific steps that we can do to get that job. First tip here. Probably one of the most impactful things I've done in recent years is started taking notes. So everybody that's watching this should absolutely be taking notes. I will share the slides afterwards because there's a lot of links and whatnot, but taking notes is a great way for you to be able to stay engaged and make sure that you're actually capturing what's being said. And that goes doubly for when you're out in the business world. Taking notes in meetings or interviews will advance your career faster than almost anything else. Smidgen about me. Like I said, my name's Brad Llewellyn. I work for an organization called Centelli Solutions. We focus on data science for large organizations. We help them kind of unravel what it is and how they can use it to advance their business. And we also actually help them deliver on their data science needs. My role specifically revolves around what we call data science enablement, meaning I don't do a lot of hardcore coding in R, Python, or things like that. I do a lot more architecture and discussions with customers to help them get there. One of the things I like to point out on this slide, because this is my one chance to show you how we should be presenting ourselves, or at least how I believe we should be presenting ourselves. When we look for jobs, when we're talking about ourselves to other people, trying to pitch ourselves, a lot of people will talk about how long they've done something. And there's a reason for that. And the reason is because a lot of people like to draw a corollary between how long you've done something and how skilled you are at that thing. That's not always the case. And oftentimes it leads employers to looking for, I need a Python developer with 7 years of experience. And that's a unicorn. And it causes a lot of us to feel like we can't get that job, even though we may be adequately skilled for it. So one of the things I'm a huge proponent of is showcase your skills through certifications. And you can see I've got a number of certifications. I've actually got even more than what's on there. And that shows an employer immediately that not only am I skilled enough to do a job, but that I have someone else that verifies that. And Microsoft has some of the best certifications around, and we'll talk about those throughout the presentation. For those of you that want to reach out to me, you can find me on LinkedIn and Twitter and my blog at Breaking BI. I'm also a co-organizer of the Charlotte BI group in Charlotte, North Carolina. So if you're around that area, we would love to have you. Before we get into what is a data scientist, we first kind of need to level set on what is data science. And it's a very big buzzword and the whole reason that we have to talk about this. So some of you may recognize this right here. This is the Gartner Data Analytics Maturity Pipeline, I think is what they call it. It walks through the steps that most organizations go through on their data science journey. So when I think of data science, and this is what seemed to be throughout my career, it seems to be kind of the second half of this. Definitely a lot of work in predicting what's going to happen and a lot of work in what can we do to make it happen. It also stretches back a little bit into talking about why particular things happened. To make this a little easier, I don't like to use the word data science too much because it's such a buzzword. So I want to replace it with another phrase that has a bit of a tighter meaning, and we'll call it advanced analytics. And we'll see that throughout the presentation. So the purpose of advanced analytics is to be able to derive more value out of your data, more than just basically what happened. Anything above that is what we're going to call advanced analytics. So today we're going to have a short snippet on some basic job search and interview and career advice I've encountered throughout my career. And then we're going to talk about the 3 different types of data scientists that I've seen throughout my career. The first type is what you would consider a traditional data scientist. It's what most people think of when they think of a data scientist. It's what I'm calling the advanced data analyst, and we'll talk more specifically about that. The second 2 are a little outside the realm of what people would normally consider data scientists. However, they are integral parts of developing and delivering data science solutions. And therefore, I think it's easy to argue that they provide similar value to data scientists, and they do a lot of similar work too. And by expanding what we think of as a pure data scientist, we open up more career opportunities for ourselves as well. So let's start with some basic career advice. One thing I'd like to touch on a lot throughout this presentation is the onus is on us as individuals to better ourselves. When we go to an interview, when we look for jobs, we're asking an organization to invest in us, saying, give me money and I promise I'll give you something good in return. However, a lot of us don't invest in ourselves. We go to work for 8 hours, come home and do something else. So how fair is it to ask an organization to invest in you when you're not willing to invest in yourself? And we'll cover a lot of different ways throughout this presentation that we can invest in ourselves. First way is self-paced learning. I'm a huge advocate of this. And as we said, and we'll mention it again, certifications are a major way to do this. And we'll give specific certifications for each of the roles as we go on. Another thing that I've seen people do to different levels of success is building things on their own. So when we go home and say, okay, I really want to learn Python, I want to learn R, I want to learn Power BI, or whatever it is we want to learn, a really easy way to do that is to just start using it. And I found blogging to be a very good way for me to teach myself things, but I've also seen people build their own projects, go to things like hackathons are another great place to do it. So that gives us a concrete objective that we can do to actually teach ourselves something. A big advantage of that is it's completely free. It doesn't cost you a dime to download R or Power BI and start building things. Next, and I'm obviously preaching to the choir here, but webinars and online courses are another great way to learn things. There are a lot of free ones, just like this one. So definitely expand your horizons and learn by watching industry professionals who like to teach. Getting a little on the topic of resumes, I'm not a resume expert, just a few things that I've had to learn the hard way throughout my career. Definitely emphasize certifications and blogs and training. This is especially true for those of us that might not have a tremendous amount of data science experience or advanced analytics experience. I was really glad to see in the poll that a lot of people are trying to transition into data science, because that's exactly the audience I was trying to hit with this. So if you don't have that advanced analytics experience, one of the best ways to show that you can do the job is to get these certifications, to write these blog posts, to build these projects. Next, as much as I hate it, we have to use buzzwords. A lot of hiring managers won't even look at your resume if it doesn't have the words SQL or Hadoop or R or Python or whatever it is that they're looking for. So if you're looking to advance into one of those jobs, you absolutely need to put that on your resume, big bold letters somewhere, make it stick out so that they know that that's what you have. And finally, one that doesn't often bite people, but when it does, it bites hard, is professional contact information. I actually read an article the other day of a woman who was completely unable to get callbacks from any of her requests for interviews, requests for meetings. And turns out that her contact information, her name from her email address, something you never get to see, her name was something she wrote in high school that she thought was funny at the time, but now is neither funny nor professional. And that name alone was causing nobody to ever give her a call back. Fortunately, one prospective employer actually emailed her back and told her about it, and she was able to get it fixed. So professional contact information is also another important one. Here's where we get to the really important part. Certifications are the number one important thing we'll talk about today. Number two is networking. While I can't speak for everybody, I can say I have never once in my career ever gotten a call back from an automated resume system. Ever once. It has never happened. So how have I found jobs? One thing I've really liked to do is connect with people on LinkedIn, people in your area that are doing what you're doing, organizations in your area that are hiring people to do what you want to do. Connect with all of them on LinkedIn. I've had dramatic success with, let's say I wanted to be a data analyst. Go to Lowe's is a big employer in this area. So I would go to Lowe's, I would search their website, not their website, but search their LinkedIn for somebody with the title of manager or talent acquisition specialist or recruiter, connect with them on LinkedIn and send them a message saying, hey, my name's Brad. I've got this certification. I write this blog. I'm really looking for opportunities in data science or data analysis. I'd love to know if you wanted to chat. And I have gotten responses every single time I've done that. And I've had to do that maybe 20 times when I was looking for a job when I was younger. So that's a great way to get your name in front of the people that actually make the decisions. And they're almost always willing to talk to you. Next, user groups and meetups are a great place to go. This webinar is awesome. It gives us the opportunity to learn something. It's not too great for networking because we're all sitting at our desks or at home somewhere. So get out and go to user groups, go to meetups in your area. I know there's probably 20 meetups in Charlotte that are tech related. So no matter what you're looking for, there's meetups at least around here that you can do that. If there are no meetups near you, you can always travel to a larger city if it's close enough, or start your own. It's the best way to really get involved in the community. And finally, reach out to recruiters and thought leaders. We talked about doing that through LinkedIn. You can do it through your meetups as well. You go to a meetup, half the time there's going to be a professional recruiter there who works for a company that has a list full of jobs that may be relevant to you. Talk to them, tell them who you are. Hi, I do this, and they would love to put you in touch with people hiring to do exactly what you want to do. Also, not just the recruiters, the people who run the meetups are generally very in touch with employers in the area. Absolutely go there and reach out to the people in charge of the meetups, and even the presenters that are there often have connections. Another thing to point out here, one of the best things we can do to advance our careers is to get exposure. And one of the easiest ways to do that is by presenting. Mark talked about it earlier. Virtually no matter where you are, you can present. You can, if you want to present about a data science topic, you could send Mark an email right after this. That's exactly how I got this. He would love to have you on here to talk about your passion. That does a couple of things. One, it helps you learn because you have to learn enough to be able to teach others. But it also gives you the exposure and the confidence it takes to be able to go out and pitch yourself to people. So I highly recommend all of you go out and start presenting things that you're passionate about. And if you really love your tech scene, go out and volunteer as well. That's another great way to get your name out there. In fact, I got my current job at Centelli not based on anything I had ever done in my career. It was entirely based on my presence in the Charlotte area. So this is big number 2 for this presentation, networking. Some basic interview tips. One, please prepare for an interview. I, in my youthful arrogance, would walk into interviews sometimes not even knowing where I was interviewing at, not even the name of the organization. And obviously, I didn't get any of those jobs. So please do at least basic preparation, and we'll talk about some more advanced preparation we can do here in a minute. After you know the name of where you're interviewing for and basics about the company, whatever you've been building on your own time, whether it's your blog or some custom thing or a hackathon that you went to, bring it to the job interview. Instead of playing 20 questions with the job interviewer, ask if they want to actually see what you've built. That's a much better way to show them that you're capable than to answer a bunch of random questions that you may or may not know the answers to. And finally, stay positive. I've been in exactly your shoes before. And we often get down on ourselves saying, oh, I'm not good enough because this job didn't want me. To tell you a little story, I actually interviewed for my last employer. I interviewed a world-class traditional data scientist. He had great R skills, great ability to create predictive models, and we turned him down. It had nothing to do with his skills at what he was good at. He was great, but he wasn't what we were looking for. So oftentimes, if you don't get a job, it's not because there's anything wrong with you. It's because you just weren't a right fit for that organization. So please stay positive. A few additional things. We'll say it again. Certifications. Huge. And we will talk about them 3 more times throughout this presentation. Another one that people don't often use is if you are currently employed, or if you go to school and have professors or whatever, talk to somebody in a position of authority over you and ask them for guidance. Specifically, ask if they'd like to sit down for a one-on-one. The people with the authority over you often know where you're strong and they know where you're weak. So by talking to them, you can get a little bit of insight into things you could work on, or maybe things that might be holding you back. And more on that point, stay positive with whatever they tell you. Some of us have certain issues, and the manager might point out those issues and say, hey, what's holding you back is really this. And stay positive and realize that they're trying to help you, and that if you can better yourself, your career will take off. So that was what we wanted to talk about on bettering ourselves. Definitely want the whole focus to be here on what can we do, because nobody's holding us back but ourselves. Now that we know the basics about where we would want to look and how we'd want to portray ourselves, let's talk specifically about the different roles and find out which one's right for us. So if we start by looking at the statistician or the advanced data analyst, first question is, what does this job do? So this job focuses a lot on individual analyses. Meaning you go into work, a manager says, okay, we need to know why sales are down. You might run a model to determine that. You might want to know what are we going to sell next week, or we need budget numbers, or any number of things. Those are the types of analyses that most advanced data analysts will take care of. And that process involves cleaning of data. So data is going to come in, and regardless of your situation, the data is not going to be exactly the way you want it to be. So you're going to have to manipulate it a little bit. That's often called cleaning. Once you have your clean data, you build and evaluate models. So you might build regression models or classification models or clustering or any of those other words that we've heard. And then once you've built those models, you have to present those results back out to the stakeholders. So this job usually has a lot of variety in the work that's done and a lot of exposure to different techniques. So if you're looking for a dynamic day-to-day, this might be something for you. So if this is for you, what type of titles can we look for? So the big one, data scientist. This is what most people would consider a data scientist. I have an asterisk beside it there because data scientist doesn't always mean this role. So whenever you're looking for that job, definitely pay attention to the job descriptions and look for things that remind you of this data analyst role. Also, data analyst might also be this role. Again, look at the job descriptions here. Data analysts can range anywhere from advanced Python users to basic Excel users. So definitely make sure that you read the fine print there. Also, jobs called statistical analyst or statistical modeler will almost always be some variation of this. So if this is the job we want, what are the job requirements? This is the only one of the three that really requires a good math or stat background. I'm not a big proponent of you need PhDs everywhere to get everything done. I myself don't have a PhD. Granted, I'm not this type of data scientist. But a good basic understanding of things like regression and classification is certainly a requirement for this, and everything additional to that adds more value. What different types of languages or tools are used here? The two major ones are R and Python. R being a much older statistical language, and Python's picking up steam recently and becoming a good general purpose programming language, as well as a good data science language. So learning either one of those would generally prove well. SAS is also just a behemoth in the large bank scene and things like that. So that's also another tool that you might use if you want. Where can we find free online training? That's the first step. I think I might want to be a data analyst. How do I learn a little bit? How do I get started? So R, there's a tool out there called R Studio. It's a development environment for R code. They have webinars out on their website that can teach you all ranges of things with R. So that's a great place to start. If Python's more your fancy, I was not able to find a single site for Python. I know there are some out there, but I found plenty of free tutorials on Google and YouTube. And SAS also has their own webinars as well, if that's where you want to go. Now that we've learned the basics, we've watched a couple of webinars, let's build something. So how do we build things? There's a website out there called Kaggle. Kaggle's a competition website where people from all over the world will submit their code and kind of crowdsource different machine learning concepts for different reasons. So for instance, if anybody ever heard of the old competition where Netflix said, if you can create a better recommendation algorithm than we use, we'll pay you $1 million. That was hosted on Kaggle. And the people that participated in that competition were everybody ranging from brand new data scientists, brand new analysts, people who had never used R or Python before, all the way up to some of the best in the world. So no matter where you are in your journey, you can learn a lot by looking at Kaggle. So use Kaggle to pull down some data sets, and you can download R or Python for free off the internet. And SAS also has a 14-day trial. So whichever one of those you want to use, there are free options for all of those. You also have the option of trying them all to see which one kind of fits you better. So I've watched a few webinars, I've learned some things, I've expanded my skills a little more by building things. Now I need to be able to show employers that I know how to do this. As we said, certifications are a great way to do this. The R certifications, there is a class on Coursera that costs $49 a month, and it's the Johns Hopkins University specialization in data science. It is a great way to learn R for data science, and it would be something great to have on your resume to show I can not only do data science in R, but somebody else has validated that. If Python's more your taste, there's an Edureka course on Python for $389. I will note that if you're looking for Python training, be specific about Python for data science or Python for data analytics, because Python is a general purpose programming language, and you may end up purchasing a class that's going to teach you Python for web development, which isn't quite what we're talking about today. And finally, SAS offers certifications for $180 per, and you can find those at SAS.com. So let's take a minute to recap what we just talked about. The data analyst is a dynamic day-to-day job where we build different models, whether predictive or prescriptive, or even exploratory, that kind of can tell us more information about our data. That's a lot of what that job entails, and it requires that math and stat background. So let's move on to another option, one that's not generally considered a traditional data scientist, but definitely plays a huge role in delivering data science solutions, and that's business intelligence architect. This is the type of role that I am. So what does this type of role do? Instead of focusing on building the models, which are more towards what we call the front end, this type of person focuses on building the structures on the back end. So preparing the data so that data science can be done on it. And after data science has been performed on it, maybe even preparing ways to report that out to people. So definitely building what's called the pipeline around that predictive model. This job builds a lot of what we call pipelines or structures. And we can see one of those over here on the right side. You can see a basic SQL Server interface. Most of you said you were either in analyst roles or DBA roles, so this should be very familiar to you. This role often builds a lot of reports. So depending on what side of this you go into, you could get that dynamic day-to-day experience of building different reports for different reasons, kind of like the advanced analyst, just without the predictive model piece. Or you could focus more on the pipeline piece, which is less dynamic day-to-day, but provides more of a construction mindset of you're building something that gets larger and larger over time. If this is what you're looking for, what type of job titles can you find? The two most common ones I see is report developer and database developer. They almost always mean some variation of this. You can also find these jobs under data engineer and data modeler. But again, be careful when you're looking through those because data engineer might mean a big data engineer, which we'll talk about in a few minutes. And data modeler might mean the predictive modeler that we just talked about, being called the analyst. So definitely read the job descriptions for those. What are the job requirements here? These job requirements get a little more lax, and out of the three roles we're going to talk about, this definitely has the loosest of backgrounds. A math and stat background, I still think really helps. It's what I come from, and it's certainly helped me. But computer science backgrounds can also help a lot here too, because at the end of the day, we are programming, and that will be helpful. If this is the space you want to go into, some of the common tools that are used is SQL Server and Power BI are two really big tools. And Azure is the cloud version of those. I don't think we need to get into what Azure is given the audience we have here. So what if this is the job you want? So I don't really want to go into the specifically building the predictive models. I want to focus more on how we get those results to the end user. Then let's start by getting some free online training. One of the things I love about Microsoft is they have something called the Microsoft Virtual Academy, right there, mva.microsoft.com. Almost anything you would ever want to learn about a Microsoft product, they'll have tutorials on there for you. And even better, if you're studying for an exam, because Microsoft also owns the exams, they have study guides or even like 8-hour courses for free that you can watch that will teach you everything you need to know to take the exam and get that certification. I also love to get a shout out to a consultancy down in Jacksonville, Florida called Pragmatic Works. They have a lot of free courses that they offer. So if you're looking to learn more about the Microsoft data side of things, you might find what you're looking for there. I also have been collecting ebooks throughout my career that I've used to study for my certifications. So if you're looking for those ebooks too, you can just ask me and I might be able to send you a copy. Now that we've watched a couple webinars and learned the basics, how do we build something? The elephant in the room here is Power BI. If you're looking to get into BI and you don't know much about it, Power BI Desktop is free, and it's a great way to learn all of the different aspects of business intelligence and data pipelining. They have their own sample data sets at Power BI sample data sets, powerbi.microsoft.com/whatever you see there. You can also download your data off of Kaggle as well and manipulate it there. Take that and build some what are called data models and reports, and that'll give you a good feel for whether this is the type of job that you want. If you're more developer friendly and you want to go the SQL Server route, SQL Server 2016 Developer Edition is completely free. 2017 Developer Edition is now free as well. So you can download those and install those on your machine. Or if you want to look more towards the future and get comfortable with the cloud, Azure has a free trial that includes sample data, so you can spin up some Azure SQL databases and play with them there too. So we've watched our webinars, we've built something. How do we get certified? This is where I really think Microsoft just kills the competition. They have great certification programs. The two main certifications are what are called MCSE. It stands for Microsoft Certified Solutions Expert. I can't speak for everybody, but I can say anytime I see anybody with an MCSE beside their name, they go to the top of my pile really quickly, because it shows that you have a very large breadth of knowledge in Microsoft data, and that you can deliver those types of solutions. All of their exams are $165 per. I will say that MCSEs take anywhere between 3 and 4 tests each, so it's not $165 for the certification. It's what, $480 to $620. I can't do math in my head like that, but somewhere between $500 or $600 to get the certification. So if you're looking for traditional SQL Server, there's an MCSE called Data Management Analytics, which there are a lot of different ways to get to that, and you can look at those. If you're looking for Power BI, there's a Power BI exam called 70-778. Having that on your resume would definitely be a good starting point for getting into Power BI. And if you're looking to get into Azure, the MCSE in Cloud Platform and Infrastructure covers a lot of that. Interestingly, Microsoft's just started to release a new set of certifications. So there's actually a way now to get your MCSE in Data Management Analytics taking only Azure tests. So there's an MCSA called Data Engineering, or Azure Data Engineering, or something like that I'm currently studying for, and that gives you a lot of Azure exposure. So regardless of which tool you want to use, Microsoft has great certifications for that. Let's recap that. So the advanced data analyst that we talked about focuses on building those predictive models. The BI architect focuses on how do we get the data to that model, and how do we deal with the results from that model. So it's the wrapper around that. It's the whole structure that encapsulates that predictive model. To look a little bit more towards the future, we can look at the big data architect. So the big data architect is an awful lot like the business intelligence architect. The only difference is they deal with a different structure of data. So when data gets large enough, and most of the people here being analysts and DPAs would understand, once data gets so large, what we call relational structures just no longer can function. So we start building what are called distributed structures, and things get a lot harder from there. The main reason they get harder is because the technology is just not quite there. SQL's been around for so long, it's so easy because everybody knows it. These big data technologies are not nearly as mature, so you have to learn a lot of programming languages and whatnot to utilize them. But as we can see with the tasks, they focus on building similar things. They still build pipelines and structures. The only difference is they build them in a distributed fashion. And instead of doing a lot of reporting, this role does more analysis. And that's because even basic analyses get difficult in big data. So we don't often find power users that can do their own analyses off of Hadoop clusters and things like that. So this is what I'm looking for. What type of titles should I find? The two big ones would be Big Data Engineer and Hadoop Developer. If you see those, you're almost guaranteed this is what you're looking at. However, you might also find Data Engineer being this type of role. Like we said before, check the job description for Data Engineer, because they might be talking about something more in the relational space and not the big data space. Given this, what are the job requirements? Math and stats are still extremely useful here. Computer science becomes a lot more helpful here. Like we talked about, most of the big data technologies require you to use some sort of advanced programming languages like Scala or MapReduce or things like that. There are some easier languages out there to use, but we won't talk about them here. What tools are used for this? Hadoop is the big one. Hadoop is probably the world's most popular distributed framework. So most big data jobs you find will be using some variation of Hadoop. Python's also a very common programming language for big data. And here's where Azure really comes into play. There are very few organizations out there that are doing on-prem Hadoop because it's incredibly difficult to maintain, and it requires very highly paid experts to maintain an on-prem Hadoop cluster. Azure makes it a one-click experience, basically. So if you're looking to get into the big data game, getting comfortable with Azure is a great way to do that. If this is what you're interested in, how do you find some free online training? Hadoop is run, managed, owned, I'm not sure the terminology, by a company called Hortonworks. And they offer webinars that you can use to learn Hadoop. Again, Python. I was not able to find a single site. But like we said, here's where Azure really comes into play. If you're looking for getting into big data, specifically in the Microsoft space, Microsoft Virtual Academy has a bunch of different webinars about how to use the different Hadoop distributions like Spark and Kafka and Storm and all that stuff. Also, Pragmatic Works has some courses on big data. They don't cover too much into it because they're more traditional BI, but you can certainly look there. And of course, I have a few Azure books as well that may be helpful. Oh, that was not what I wanted to do. Now that we've watched a webinar or two, we start building. If you're brave, you can try to install Hadoop on your local machine. I am not that brave, and it is not a simple task, so I wouldn't recommend that people just dive straight into that. But the option's there if you want it. Again, we've talked about Python, completely free. If you want to get started with that, you can find data sets on Kaggle. Here's where the Azure trial really comes into play. If you're looking to get into big data, spin up your Azure trial and create a few different things. There's something called HD Insight, which is Microsoft's version of Hadoop. So you can spin up an HD Insight cluster and learn how to use that, or you can spin up something called Azure Data Lake Analytics, which is Microsoft's proprietary version of that same type of technology. Where can we find some good certifications? So if we're looking for Hadoop certifications, Hortonworks offers them for $100 each. You can find it at that website there. We have the same Python and Azure certifications that we've seen before. Adding in that there's now that MCSA and Azure Data Engineering, which has an entire test on HD Insight. So you can look there as well. Now, we have 15 minutes left and we'll want to do a short review and then open this up to questions. The statistician or advanced data analyst. What is this job all about? They build the predictive or the prescriptive models. A lot of R, a lot of Python or Scala or whatever language you might end up using for your modeling. If you don't have a math and stats background, it is a pretty high barrier to entry. You have to know a lot of different machine learning and predictive models to get into that space. The demand here is very high, and it will remain high for a while, but we are going to see it decrease in the next 5 to 10 years, not because there's not going to be people doing it, but because there are a lot of automated machine learning tools that are gaining steam. We actually just saw the Gartner Magic Quadrant for data science come out recently, and a company called H2O.ai shot from middle of the pack to being a leader. So that's definitely a space to look at over the next 5 to 10 years of tools that do the predictive modeling for us and leave the pipelining to us. The business intelligence architect, they focus on building the relational structures instead of the predictive models. This has got the lowest barrier to entry out of all of these. So if you're just starting to get a job or you're looking for a non-tech transfer, this is a great way to do it. It's also an easy transfer for people who have been DBAs or been in the data realm somewhere else. Demand of this is still very high, and honestly, it's going to stay high for a long time. It's Microsoft's bread and butter, and they've built their entire data platform off of it. If you want to be more forward-looking, the big data architect does similar things to the business intelligence architect. The only difference is they build the distributed structures instead of the relational structures. This has a very high barrier to entry because the tools are honestly just difficult to use. They require a lot of knowledge to spin up and maintain these Hadoop clusters. The demand is currently not super high for these types of jobs. Most organizations aren't there yet, but we will definitely see massive increases in this as time goes on. So this is definitely something to keep our eye on for the future. As far as my 2 cents about what's the easiest way to get into data science, I'm a believer that the easiest way is through business intelligence. It has a low barrier to entry, And then once you have some core background, so some core knowledge in Power BI or some core knowledge in relational databases, then you can add on predictive modeling to that, or you can add on big data to that, and it really gives you a lot of options versus jumping strictly into the advanced data analyst or the big data architect can sometimes be daunting. Now that we've talked about all of that, we've had a review. Where do we get started? Step one, choose a role. Pick which one of these three you like. You can change your mind later, it's not set in stone. So pick which one speaks to you right now. Follow the provided links in here to get a relevant certification. Prepare for that certification using the books, the webinars, the build your own projects, and get certified. Get that MCSA or MCSE beside your name. But while you're doing all of that, don't just do it in a vacuum. While you're doing this, reach out to recruiters and managers on LinkedIn. Go to user groups. Go to meetups. Go to other technical events like Past Summit or like SQL Saturdays, and network as much as you possibly can. Because even though you might not have that Power BI certification, you might not have that R certification yet, a lot of employers might look at what you're doing, how you're putting that effort into it, and hire you anyway, and then pay for those certifications for you. So networking is key here. I definitely want to thank everybody for coming to this. My contact information's there. If you want to send me an email, you're more than welcome to. I do give some other presentations around other things. I believe that Azure Machine Learning Studio is another really great way to get into data science for people who might not be extremely strong in math or stats. But other than that, thank you for your time, everybody, and I'm open to questions.
Okay, thank you, Brad. I surely appreciate the tips today. I have been answering a lot of the questions in the question box, and now's your chance to put questions into that box for anything that you want to ask. But Brad, I'm going to get your answer for some of the questions that I've answered, but just to get your take. First of all, someone said that their math knowledge is very stale. What are your recommendations for brushing up on math skills for data science?
If you're looking for that analyst role and you want to get back into predictive modeling, a great way to use your skills is to get that R, that Python certification for data science, because it'll take those regression skills you learned or those classification skills you learned in school, and it'll modernize them to use modern tools. So if you've already got that background, those certifications are a great way to get moving.
Okay, and I love that answer. And I had a complimentary answer talking about math courses on the MOOCs and even on Khan Academy if you just want to learn raw probability and statistics is an option. So here's another question here about how is the advanced BI architect different from a DBA?
So the DBA generally focuses on keeping the machines up and running. So it's a lot of maintenance and upkeep, versus the BI architect focuses a lot on how can we get the data to the end user. So for instance, DBAs often focus on are my queries running? When are they running? Is anything failing? Are they running slowly? Those are the things that DBAs tend to focus on, versus the business intelligence architect tends to focus on what are the requirements for this type of report? What type of analysis are we trying to do? What type of predictive models are we trying to productionalize? Those are the types of questions they answer. But they are complementary skill sets.
Okay, that's great. And I mentioned in my response to team data science process, which I probably will give a presentation myself in the upcoming month or two. Next question here, are there any recommended books or sites specifically that give a crash course on statistics?
Mark had a good answer with going to Khan Academy. I don't really focus on looking around for statistics training, but I would say Khan Academy and Edureka and things like that are all offer their own statistics courses.
Right, and I'll add to that. There are a number of free books online for statistics or in the area of data science. And by the way, some of these authors give their book in PDF or HTML format, and they also sell it on Amazon. So we're talking about legal giveaway available at the author's website, from either their university website, so you can look for those. And again, if we're giving an answer now, feel free to follow up either with Brad or myself on that question on statistics. So here's a question here from John about a master's degree. And the question is here about a master's degree from a university math department or a math degree from a business school. Brad, do you have an opinion on that?
I don't even know if that was really a question, but
Right. So the question is, if they had a choice, a master's degree from a math department or a master's degree from the business department, do you have a opinion about that?
unfortunately, I can't speak to masters in business, and I certainly wouldn't say one thing or another. But the more math you can get behind you is always is going to help you. So, however you
Right.
get that is up to you.
Okay, so I will answer this question. I have a doctorate from an engineering program. My particular interest was knowing math in a more deep way, and of course, I was planning for a long career, and so that was 20 years ago, and I have reaped the consequences, and that I love that. Recently, I wrote a course for a business school in the Atlanta area, and this was an introduction to data science course, and we used I can't think of the book right now, but the focus, oh, I do know the book. The book is Data Science for Business. So if you want to, that's just a course. That is not an entire degree, but a business school will have a different focus. And the focus of the business school will be perhaps aligned with their MBA program and teaching courses more in the business area. That is a slightly different type of career. I think Brad talked about a number of different careers. And I would be happy to continue discussion offline for that. Okay. And then Brad, so at the beginning, I did prompt it with some, and John says thank you. I did prompt the beginning by showing that there were no particular data science listings at the moment on the past website. Where might people find jobs listed?
That's
Where do you link them?
that's a great question, and I'll go back to my earlier point. I can't speak for anybody else, but I've never found a job online that's ever contacted me back. So people have jobs, and the best thing I've ever done to find jobs is go out to user groups and meet people or connect with people on LinkedIn directly. I've not had good luck in my career finding jobs off of websites.
Okay. And I'm going to share a little Mike story. So Brad talked about networking. Currently, I work for Microsoft. The reason I am at Microsoft is because a hiring manager saw me do a presentation about 4 years ago at a SQL Saturday. I was volunteer presenter, and that manager happened to see me that day, and that's years ago, and remembered me, contacted me on LinkedIn on a Thursday. I was talking to him on the phone on Friday, and by Saturday, I was talking to some of my friends at Microsoft. So certainly recommend LinkedIn for opportunities. There are many listings there, and then also just to get an idea of job market. So let me tell you what I do get out of the search engines. What I do get is an idea of what the market is. What type of skills are people looking for in your area? And by the way, and I think Brad, you might agree with me on this, the amount of data science opportunities are not uniform across the United States and certainly not around the world. So and while there are opportunities that allow you to work from home, like for right now, my job is a work from home, travel to client, and many consulting organizations have those types of opportunities. The path in is what Brad said, and so I'm gonna double down on what Brad said earlier about the certifications, being known in the community. I happen to have been a Microsoft MVP when I started at Microsoft, so that does help, and it gives them a confidence that I do know the technology, that I have a proven track record at presenting topics to the general public, because guess what? The first thing they're going to do is they're going to want to send me to a client, and there's no backup. So you know what? I am the data scientist. I'm going to have to represent the technology and represent it well. There are paths forward. I would certainly encourage what Brad said, networking in your local area. If there's any data scientists that you know or other people that are in your area, try to find out who they are. I also recommend quote unquote blind contacts, and that is that if you know people who are like executives at technology organizations in your area, you can just go to them on LinkedIn and say, you know what, I'm not looking for a job right now. I want to know about your career and what it needs, what does it take to do well in this industry? Can I take you to lunch? And some people may respond to that. So that's an opportunity to learn what's going on in your area. Brad, so certainly I've appreciated having you today. Could you preview for us what you're going to be presenting next week?
Sure. So next Thursday, I'm giving another talk. This one is not on career development. It's actually on the technology stack. So it's called Four Paths to Data Science Success Using Microsoft Azure. And it talks about four of different case studies I've seen throughout my career of how we solve quote unquote data science problems using different types of technology in the Microsoft stack, some of which aren't even considered traditional data science tools. So it's a good way to expand our horizons a little bit.
Okay, that's great. And by the way, we will see this presentation. I will be posting it to YouTube, our YouTube channel, and then I'll send an email reminding people that that is posted. Of course, many people cannot particularly attend during a live presentation. We're all working, or a lot of us are working, and or may not be able to attend live, but we will have those recordings available for you later on YouTube. So thank you, Brad, for presenting today. We certainly look forward to having you next week. And again, feel free to contact Brad or myself with any questions about any of the topics we talked about today. And thank you for attending.
Thank you, everyone.